Welcome. Let us discuss about application of stacks. As you see, stack is a data structure. What we call is LIFO data structure, last in first out data structure. You have seen in our previous discussion that how we actually implement stack using both array and linked list. And in this discussion, I want to talk about application of stack. Some direct applications are there, like conversion of tail recursive algorithm to iterative ones. This is a recursive algorithm that can be implemented using iterative technique, keeping track of method calls, because method calls which is called when and it is running on the stack, it is maintained using stack data structure. Evaluation of arithmetic expression is very common, and I'm going to talk about this one actually in this discussion: infix to postfix conversion, infix to prefix, and evaluation of postfix. Some of the indirect applications are also there, like auxiliary data structure for some algorithms. Example, you convert a decimal number to another base, for example, hexadecimal number and so on. You know what happens, you divide by number and then you come back from last to the first. So it's actually concept of stack. Component of other data structure example, we use implement a stack in a tree structure. So let us look at the next discussion is that application of stack, how we evaluate a postfix expression. This is an expression. Within the bracket we have 5 plus none. What we have is a operator, and then these operators are inside the operand, so we call this expression infix expression. Our target is how can we convert an infix expression into infix means operator is inside. So the order of operation evaluation is determined by the precedence rule and parenthesis. Parenthesis means it's always the first operation, then multiplication, then division, then addition, and then subtraction. So when an evaluation order is desired that is different from provided by the precedence, parentheses are used to override the precedence rule. But let us look at application of stack. How do we evaluate a postfix expression? Expression can also be represented using postfix, means operator comes after. That's why post. And pre means operator comes before. So where an operator comes after its two operand is postfix. Prefix means where the operator comes before its two operands. Every operator needs two operand. So the advantage of postfix and prefix is that it's actually unique, and you without the need of precedence rule. So what happens, like infix is this, you can see in this example 16 divided by 2. If it is going to be postfix, then this division comes at the end 16 2, and if it is a prefix, then it comes like this. So in this case you can see the infix, the postfix, and the prefix expression. But I'm going to show you how do you convert an infix to prefix and postfix very easily. Take a look at this one. Infix to postfix conversion manual is very easy. It's actually three process completely. You first need to parenthesize the complete expression and then move each operator to its corresponding right if it is a postfix, and if it is a prefix, then move to the left and remove all parentheses. For example, you see here, this is a given expression. What type of expression it is? It is an infix expression, 3 plus 4 multiplied by 5. What we do in the next step, parenthesize, put all parentheses, cover the even outer parentheses, and now you start moving the operator to the enclosing parenthesis. That means this multiplication comes in between, then plus comes outside this, because you have to move the operator to the right out of the enclosing parenthesis, and finally it looks like this: 3 4 5 multiplication plus. Same goes with the next example. You can see a divided by b square c minus c minus d multiplied by e minus a multiplied by c to the power of 3 to the power of 4. So what we do, we put putting the parenthesis a, then this actually is one parenthesis, then we cover this, then we have another parenthesis here comes in, but you can understand this is actually whole power. So what happens, what we do, minus a then multiplied by c to the power of 3 to the power of 4, and then we start moving all operators to the enclosing parenthesis, right of the enclosing parenthesis, and then finally it looks like this. So you can do this in the paper and also recall and recheck this whether it is right. So infix to prefix, the other way around, you do parenthesis and then move to the left. Move to the left, you become, this is an infix, then parenthesis, then operator is moving to the left of the enclosing parenthesis, and finally prefix expression. And then, so this is a very clear concept of how do we convert an infix expression into postfix and prefix expression. Application of stack, evaluating postfix expression, what we do generally in this case, we start with an empty stack, alright. Then for each item in the expression, if the item is an operand, if it is an operand, then you push that into the stack. Otherwise, if the item is an operator, because operand and operator means if the item is an operator, then you have, every operator needs two operands. So you have to pop operand 1 from the stack, operand 2 from the stack, then do the operation, and finally push the result into the stack. That means if you are getting an operand, you push that operand means you understand that number you want to actually add or multiply or divide, whatever, that is an operand. I show you again, I'm going to show you the simulation. So operand means you push, operator means to pop, then operation between the operands, and the final result you also push. So pop the only operand from the stack, that is the result of the evaluation. So consider in this example we have a postfix expression like this, which is, this is the infix, and the result is this. How do we trace this postfix evaluation algorithm using postfix expression? Look at this. This is my postfix. I push 2 and then 10 coming in. Then what happens? The plus comes up. So plus means you are actually now pop and then do operation and then push again. So 12 is pushed. So you to understand, you push 2, push 10, it is in the stack. Then operator plus comes, again operate, and then finally you have 9 6 9 6, push 6, they see push 9, push 6, and then you have actually, you can understand that you have minus operator coming. So pop 6, pop this one first, then pop 9, then 9 minus 6 is 3, and then push this 3 into the stack, now 3 and 12. So next operator is a division, so pop 3, pop 12, so 12 divided by 3, 4, and final answer in the stack is 4. So how you are evaluating a postfix expression using stack, this is actually an answer. So it's basically showing you how do you actually convert an expression into postfix, and then finally evaluate that postfix expression to find the value. This is a pseudocode. So see this example. What happens in step 1? While stack is not empty, stack.pop apply to postfix. So what happens? This 1 is coming in. Let me go to the previous one. Then you can see 1 is the directly output because I'm converting actually an infix to postfix. So this 1 directly comes here. Then minus is pushed into the stack. Then step 3, you can see 2 comes in, 2 here, and then again another operator, power is coming, so power is pushed into the stack, and then you have the next is the 3 comes in, the 3 comes here, and again your another operator comes here, so it's push again into the stack, again 3 comes here, so 3 is here, and you have 3 operators, and finally you have actually, when you are getting, suppose when you are here, you have actually got another operator minus, you are actually popping all the operators. What operators you pop? This power including minus, because there is a bracketed term, so you automatically stop here, and then your next bracket push is here, and then 4 comes here, 4, and then automatically plus comes here, and then finally your 4 5 is here, and now you have this operator. This is actually converting an infix to postfix using a stack. And then finally what happens, you have this 4 5 comes here, and then you have this multiplication is pushed, again your 6 is coming, and then closing bracket comes means you have to pop again, pop up to this bracket. So you have this pop up to bracket has come, and finally you have a multiplication again push, and then you have now actually in the you have actually this multiplication and subtraction, and now you have a 7. Finally 7 comes here, and then after that you actually pop both, and this is your final postfix expression from infix using stack. So application of stack, we basically have reversing the infix string, perform the infix to postfix, and infix to prefix conversion. See, infix to prefix means you first do reverse the infix, then infix to postfix, and then reverse the postfix. For example, you see this is actually an infix. What we do, reverse the infix. This is a reversal of the infix. Yeah, reversal of infix. Then infix to postfix, and then reverse. So you actually convert an infix to prefix using postfix conversion algorithm. Alright, so this is all about the stack applications, and let us follow some example and some exercise also, and enjoy data structure computing.